So here we go. This is going to be one of the more challenging pictures I'm going to have you guys draw, but I want you to draw it. I know you can do this. I've done this with classes of eighth graders many times before, and yes, you can draw this. So just whatever I draw, I want you to draw. I do find that if I just showed it to you, you'd go, I can't draw that. But if I draw it for you, you can copy along what I do. Okay? So what we have here is a circle in the center, and that represents the sun. Okay, I'm going to put those interesting shapes right next to it that suddenly makes it look like the sun. Okay, or I could make it look a little more sunlight, put some sunbeams on it. I don't know why I give my son sunglasses, but there's the sun. Okay, sun shining. Now we have the earth. So where do we want to start our cycle of the seasons? How about we start the cycle of the seasons at summertime? So summer's over here. And by the way, this isn't the easiest thing for me to draw either, but I want to try to make this look three-dimensional, right? And so I'm going to draw the equator, try to make it look sort of three-dimensional, like put that little line there. It's not straight across, it's got a little bit of curve to it, and this is the line of the axis of rotation, okay? So that means that the northern hemisphere is tilted toward the sun. Now we're going to be northern hemisphere snobs here and only talk about the seasons in the north. And it'd be opposite in Australia. So this is what we call this is the longest day of the year, the maximum tilt. It's called the summer solstice. Summer solstice. Okay, draw that. If you need to stop the tape and copy it, go ahead. But moves on, and it goes around the sun. Now it's trying to go around the sun, right? I'm trying to make this look sort of three-dimensional. And this, it goes counterclockwise, by the way. And this would be summer. Yay, summer. Okay, now what we want to draw. Now, what's the date where it's equal? It's called the equinox, right? And being after summer, winter, spring, summer, fall, this would be the autumnal equinox. Again, trying to make it look three-dimensional, like it's tilted. Actually, my tilt is a little exaggerated, but that's okay. The autumnal. Having to do with autumn, right? Autumnal equinox. Equal night. That's a Q. Equinox. All right, so there it is. It's not tilted toward the sun or away from the sun. It's kind of tilted 90 degrees. And then it goes around until you have maximum tilt away from the sun. That's called the winter solstice. Again, I'm not sure what this part means, but sol is Latin for sun, right? And then this would be winter, and then autumn or fall. Autumn. All right. And then here we have winter begins, which strangely enough, like I said, a lot of people find it hard to believe the days are actually getting longer during winter, but they are because it's going up towards spring. And this is called the spring equinox, but there's another name for it, which is the vernal equinox. You might guess that vernal means spring, right? Equinox. And honestly, I don't care if you know the word vernal so much, so we could just say spring equinox. That's fine with me. Okay, and so what we got winter going on here. So these landmarks really are just, they are at that moment where it's the maximum tilt toward or away, or even Steven, right? And so these are the beginning of each of the seasons. Winter, spring, and summer and fall. Okay? Those seasons are caused by the earth going around the sun, right? Revolving around the sun in its orbit, and the fact that it has a tilt. If the Earth didn't have a tilt, we wouldn't have cycles of the seasons. It would just be hot in the equator and it'd be cold up north. The reason we have seasons is because of that tilt, which changes the angle of the sunlight as it shines on the Earth over the course of the year. All righty, there you go. So I hope you drew the drawing. It's trying to draw a two-dimensional image of what this is a three-dimensional model of. The Earth going around the sun, maintaining that tilt in its axis. And what we have, we got summer. What comes after summer? Autumn, winter, spring. Okay, so you can expect when we have a test on this, I'll have a diagram on the test. It's kind of like what you're going to see in the questions here. It's going to look a lot like this, and an A, B, C, D, E, and you got to be able to identify it. So keep this piece of paper right there. I can't guarantee that I'm going to have the tilt in the same direction. I might have summer and winter reversed. It all depends on the tilt of the axis. If it's tilt toward it, that's summer. Okay, you should know that. All right. Good.